started. No, save your time, but everybody heard that, didn't they?
Yep.
Yeah, cool. Fantastic. Okay, so we're on session 2 now of Fusion 360, run by the fabulous Tim. And I think today we're going to be adding some gears and bearings. Tim, is that right?
Yep, that's it. And so as a reminder, let's see here. I'm looking for, here we go. I'll just share this for a quick second. This should have been available somewhere, but here's the concepts I want you to listen up for when I say one of these little buzzwords. These are the things that will help keep your designs from getting too tangly. And so you'll see these tips and tricks as I demonstrate them as I go through this build. And stop share, and I'll go right over to Fusion, and we'll get right into it. And share. All right, everybody can see the Fusion screen?
Yeah.
All right. So this is the file where we left it before. The only thing I changed is the body rings. I just had that for context of where we are in the build. We're in the droid. And I did rename these two little pieces to magnets, because in my mind, what we were building is a little lighted zapper looking attachment that will magnetically attach to the to this lifter assembly. So in my mind, we're going to send some wires through the center of this, and it's going to magnetically attach with some kind of pogo pins, and at the end we'll have some kind of laser looking thing that'll flash with lights. That's in my mind what I was designing. Whether it ends up being that or not is a different story, but right now we're just concerned on building the lifter. So again, just as a quick recap, we have our lifter servo that we placed in here from the chopper design, and it's got the clearances set up so that gear is going to appear right where it needs to in relationship to the rest of the build. All right, so probably the first order of business is to figure out where the second gear is going to go. And if you remember, we had a little chart that I built with someone's echoing. And I built a little chart with the gear teeth, and I believe it was 44 gear teeth we want on this. And let me just take a look real quick. I'll cheat and look at yeah, 44. So we're basically going to do is try to build this blue gear, and we'll go from there. All right, so where do we want that gear to sit? Actually, we know it's going to have this bearing here. So let's so we want the gear to sit with a little clearance off of this surface here. So I'm just going to put my offset plane off that surface and say, well, 3 is probably too many. Maybe 1.5 millimeters is where I want that gear to sit in relationship to the other. And what that does is it's going to be a slightly thinner gear, and it's going to mesh with this bigger gear, and it's going to have a little wiggle room there in case it's not perfectly aligned or perfectly flat because of the inconsistencies of 3D printing. So how do I make a gear? There's lots of ways of doing it. You can go on the internet and learn about all the math, or you can skip to the easy part where they give you tools that are built into Fusion. They're not great tools, but they work. So if you click on the Tools tab at the top and you go to Add-ins, Scripts and Add-ons, and scroll to the bottom, you'll see there's 2 ways of putting a spur gear into your design. Here's a little caution. If you click on one of these and then try to run it, it's going to crash Fusion, because right now we're in something called direct modeling. It likes to have a timeline. So to do this, I'm just going to go to Capture Design History. Don't worry, I won't leave it on long. And you'll notice we get a little timeline show up at the bottom. So now when I go to my add-ons or add-ins, and I haven't found a functional difference between the two, but let's just say we'll pick the bottom one and hit run. And that brings up this little dialog that creates a spur gear. If you recall from our module before, I'm just going to use a module 1 because I know the other one has used a module 1. I'm going to use 44 teeth. Backlash, I'm not going to mess with. Gear thickness, let's go with 10 millimeters. And the hole diameter, I'm just going to use that as a place marker right now. I'm going to drill the hole to something bigger. Let's just go with 3. And you notice I get a little error here. It says the root fillet can't be bigger than that. So that's just, if you're asking it to do a root fillet that's bigger than the teeth size, it has a problem. So if we look at what it's generated or about to generate here, it says pitch diameter is 44 because my module is 1. So I'm not doing any scaling here. I'm just using the 1 millimeter metric, and it's going to mesh because my other module is also 1, and those are required if you want your gears to mesh. And the pitch diameter is 44, and this one was 72, if you recall. So you take half of the diameter, or the radius plus the radius, and that's how far apart the centers are going to be. All right, so I'm just going to hit OK, and voila, it makes me a gear. You can see it appears just randomly wherever it decides that gear should be. And now, just to stay in step with everything, I'm going to go do not capture design history, and then it's going to erase my timeline, and I'm back into direct modeling mode. All right, so how am I going to get this gear over to here? Well, probably the easiest way is to go back to the solid workspace, create a sketch. We'll sketch on this plane, and for some reason Fusion likes to spin it. And then I'm going to go project include, which is the P key, and bring that geometry into the build. Finish sketch. And then I simply go to modify align. And then right now it's doing a component. You notice that what I did is it says spur gear 44 teeth. See, it's got this little dot here. This is a component as opposed to a body. These are bodies inside of this project, and you can think of a component as a full project inside of another project. So it's like a sub project. It has all the pieces that a regular project does, like an origin, body, sketches. It has its own extrudes and patterns. And I like using components when I'm making complicated things because it keeps all the actual business of making that part kind of contained inside the component. You don't ever have to use components, but it will make your life easier and more complicated at the same time. All right, so object component from, and here it makes, you have to be very careful of where you're picking on this thing, because whatever you pick is going to be the alignment spot. So you can see I can pick the cylinder, I can pick this ring, which is what I want right there at the center, and this little 4-box circle hole pattern shows you the actual thing that's getting aligned. And where I want it aligned to, I want it aligned to right there. And you can see that it easily brings it in and aligns it to right to where I want it to be. If we zoom in here, it's not quite spun correctly, but that's fine. That's more cosmetic at this point. But just to make it look pretty, let's spin this a little bit to make the gears mesh. Oh, because it's a component. And there we go. All right, so that looks a little thick to me. So I'm going to hit this face here. And you can hit either extrude or offset faces. I tend to do offset faces, and because it'll preserve the geometry. But we made it 10. Let's go with -5. That's too much. That's fine. -5. All right, so that's our gear. And right now it's a component. If we didn't want it to be a component, we can just suck the body out. Let's name this spur gear 44. I could just pull it up into my main build here. And now I've got that body that I can work with and not use this component if you didn't want to use a component. But I'm just going to leave it down there for now. So I'm going to do undo paste. And now that body should be back in here. There it is. All right, so we'll just leave it there. I'm going to turn that off for now. So that's where the gear is going to go. I'm going to turn off this sketch. But what's that gear going to ride on? Well, it's going to ride on a shaft that goes through here. And it's with the loads we have on this and the plastic build, you could just use this as your bearing. But I found that you can get a little wobbliness in it because you make it enough clearance so that it rotates smoothly without dragging. Then it has enough clearance that it actually wobbles a little bit. Then you can have issues with it clearing your body door when it's it kind of wobbles on this dimension here, this plate here. So I'm going to attempt to solve that problem by putting in a bearing. Now you can buy bearings, obviously, but in this case we're 3D printing, so we're going to 3D print our bearing, and we're going to get an advantage of that because we're going to not have to house the bearing inside this device. We're going to have this device as our bearing. So
Tim's question from John, which is, do you make the smaller gears thinner so it fully meshes with the larger one?
Make the smaller gears. Let me see if I can read his. So
I think he means the thickness of the smaller gear is thinner than the larger one.
Yeah. The reason I chose to do that is these, again, they're out of plastic. So if these gears aren't perfectly aligned, I just want to make sure that the gear, the top gear here, has plenty of target to miss and still hit the gear, if that makes any sense. It's just a matter of design clearances. If this was made out of metal and everything was perfectly aligned and mounted with precision, ideally these gears could be the same width.
Yeah.
This is allowing you to have in your, say when you put it together, you didn't glue it quite right or whatever. It gives you just a little wiggle room in the assembly process that you can still successfully put this thing together and have it work without being super precise. So that's a built-in clearance or variability that I'm allowing the design to have without it getting, I mean, certainly I could make them both the same, but if you look at the construction of this bigger gear, what it really is it's housing this servo, and I run out of space here. So I have to have this bigger gear sit proud of the servo. And then when I do that, it's too thin. You can see where I've this little space here where I added this much back to the big gear. And that gives me the clearance, because otherwise I would have to push this whole gear further out. And that impinges on the clearance of inside the droid, like my card dispenser and chopper, perhaps. So it looks like we have a lot of space, but we really don't. I'm trying to conserve the footprint size of this overall build so that it's as small as possible, but still big enough to make it easy to assemble and use. I think that answers the question.
I think it does.
All right. So somewhere in here is my chopper bearing. And I'll point out this is a component. And when I click on it, you can see I have a little link here. And I have a little tool, a pencil mark. So what this means is this file is actually physically linked in my design workspace to the original chopper bearing. So if I can't edit this bearing at all at this point, And if I did want to edit it, I could either open the original file or I could click on this little pencil. You can see it takes me into sort of like a sketch mode where now I'm actually editing, and you can see that this has its timeline. This component was built using traditional Fusion timeline techniques. And then when I'm done, I end my edit in place. So if I needed to manipulate it, I certainly could. But what I'm going to do instead is I'm going to break this link, because this piece is going to get chopped up, and I don't want a reference to that original file. It's never going to be friends with it again. All right, so I just brought it in, and when I brought it into the project, you can see it's not sitting anywhere where it needs to be, and we have a few problems to solve. So problem one, this, if we go to inspect, from here to here, we can see that's 9 millimeters across. If I go to my place where I'm trying to put it, inspect, it's 10 millimeters across. So I've got a millimeter that I'm happy that I have an extra millimeter of clearance, but if I go and just align it, it's not going to be in the center of this. So two ways of solving that. Probably the easiest is to, you could align it to the center of this mass, or that's probably the more complicated. Probably the easiest is just to add a 0.5 centimeter on both sides to make it a total of 10. So that's what I'm going to do. So I'm going to take this face here. I'm going to hit Q and 0.5. You can see it grows. And on this face, I'm going to hit the, I guess it's, I'm not sure what it is on a Windows keyboard, but I guess it's the alternate key. Anybody use Windows know about how to select more than one? Maybe the shift key? No, it's the, I'm using a Mac computer with the Windows keyboard, and for me, it's the Windows key, which is weird. But anyway, there's the, whatever key it is on your computer that allows you to select more than one. You can see it's going to grow.
Control, Tim.
Control, thank you. On the Windows machine. So now I've grown this by a 0.5 millimeter. I'll just double check my math real quick. I always do that to make sure I didn't fool myself. So now the bearing housing is now 10 millimeters. That matches my base. So now I'm going to go to this component, chopper arm bearing, and go to align. And I'm going to align, oops, I'm going to turn this off. I'm going to align this. You can see it's the center of that arc with, and it really doesn't matter when you're talking circles. That's the center of the circle. And now you can see that that part is embedded happily inside of the mounting bracket. So I'm happy with that. We'll hit OK. And obviously the mounting bracket has an issue in that it's doesn't have a hole for it. So let's fix that. Probably the easiest is to go to split body. And body to split is our servo base. And the splitting tool, I'm going to turn that off for a second, is going to be this. And you can see what that does for us is it's going to, let me turn this back on. It's going to cut a hole in into the base. And I've got extend splitting tool. So now, every time I split something, I always look and see what happened with my body count. And you can see that I added a body because that makes sense. I've cut this into two pieces. So let's turn off our gear so we can see what's going on. And there's my new spot for that bearing to live in. So unfortunately, it chose the little part to get the appended name. So let's just delete that. I'll leave it for now. I don't think I'll need it later, but I'll just leave that for now and turn this chopper arm bearing back on. All right, so that's looking good. Next thing I'm gonna do is combine my servo base arm with the outer race of the bearing. And I'll hit OK. And what I did was I merged this bearing piece into the servo arm, and you can see the end result is it's got this inner, or this outer race is now built into the servo arm, and that's going to be the basis for our bearings. And just a little quick preview here. Let me turn this cage off. You can see the bearing's going to live in that little space right there. Just a quick aside, just a little sidebar. We're not going to talk about building the bearing, but these are just 6mm BBs that you can buy that are very precise. And I just, honestly, I took a bearing that is a metal bearing, and I looked at the clearances of how that was built, and I just mirrored that. And it works really nicely when you build it in plastic. And I have a video of how to put this together because it's not entirely obvious. All right, so I'm going to turn these bearings off because they're that's bearing cutters, bearings.
I guess you have to kind of snap that together, do you?
Yeah, basically what you do is you cover one side so the bearings don't race all over the table, and you start packing them into these spots. And eventually, like, you put them all on one side of the, so they're not evenly spaced, they're all kind of bunched up, and you can snap them in. And then once the final one is snapped in, you start rotating the center, and they kind of start spreading out. And then this cage, that's not fully the length of the bearings. It's just a little bit over the center diameter. And this will actually snap in and hold those in their relative positions.
Right, with it, yeah.
All right. So now that we've got, oops, let's turn that cage off, inner race off for now. And where are these bearings? Find in browser. Huh. Oh, there we go. I was just wondering why it was so hard to get rid of those to go invisible. All right, so let's go back to our spur gear, and we'll see if we can find that a home. So the way this is going to go together is that this this chopper arm bearing is going to be connected to this gear. Now we can either screw it to the gear, which is probably preferable when you're trying to put this in together, or the gear could contain the shaft that this inner race, so we could physically connect it. And if I were to print that piece, then I would install it from the inside of the droid, and then that'll probably work. So let's just go with that for now. So what I'm going to do is turn this off. Whoops. Turn this off for a second. I'm going to grab this face here, and I'm going to, now here's where I like to use offset faces. If I use extrude, it's just going to make that thing bigger. And if it touches anything like this gear, it's going to want to join or cut or whatever these objects are, which could be fine, but it may or may not be what I exactly want. Whereas if I use offset faces, I just find I have a little bit more control over what's going to happen with the relationship of these pieces without doing things I wasn't expecting. And what I mean by that is, if you go too fast with this and you start extruding things, you'll either cut things you didn't mean to by accident, or you'll join bodies that aren't supposed to be separate bodies into one body by accident. And it can be a time saver, or it can be a nightmare if you don't realize it happened until 2 hours later and you're like, why are these two pieces connected? When did I do that? Where if I'm doing this and I implicitly join them together, then I'm going to be better off. So I'm just going to use this technique and just drag it towards the direction you want to go. And then I just touch the face, and then it will exactly snap to that face. And now we're going to do a modify or a combine this gear with this inner race, and voila. So it disappears out of my chopper bearing, and it becomes a single solid piece of this spur gear. And I'll check my bodies to make sure that it actually did what I wanted it to do. In fact, while I'm down here, I'm going to turn these sketches off. I don't like that little dotted line. All right, so now I have a piece that will become the basis of the rest of the build. So let's kind of review where we're at. The bearing is going to act as the hub of rotation for this gear. The servo is going to act as the hub of rotation for that gear. And I made it look easy, but I did the math. I actually have a sketch in here somewhere, I think, that there it is, where before I determined all this, I worked out the math on the size of these two gears and the distances between these hubs, because this distance and these circles, these pitch reference circles, you can see what they are is perfectly tangent. And the length of this line is the radius of this and the radius of that. And that's how far the gears go apart, plus or minus a little bit of clearance. Because anytime you're working with anything mechanical, you're going to have clearance, because otherwise, if you get them perfectly aligned, then they're going to be too tight. They won't function properly, or you'll put undue stress on your servo. All right. So this little ball bearings here, that's the only thing left of the, and the cage, are the only thing left of that bearing from Chopper's arm. So now we've got a lion's share of this work is done for having this lifter do its job. So really now the rest of the design is going to be, what's the lifter going to do, and how are we going to get this rotation through the oops, that's not it, through this hole and into the area over here. Well, let's take a look at our hole and let's see what we're up against. Servo chopper off. Turn my spur gear off. So the way this is designed is it's got two captured nuts. One comes, they're both coming from the top, and probably an M4, if I recall. Screw is going to mount that in. And so let's take a look at this. Inspect. The diameter is 25. So we've got whatever we're going to put in here has to be smaller than 25. Maybe 24. That'll give us a healthy amount of clearance on both sides, so it shouldn't rub, even if it's not a perfectly smooth print. And it'll give us a little wiggle room when we're actually mounting it, so that we can maybe work an angle. And if we go as small as 23, that'll make it even more easy to assemble. And we don't have to worry about our whole assembly wiggling, because as you recall, we're running on these this bearing here, which is going to hold it in a pretty good orientation. But let's take a look at the relationship of this to this. That's a little bit tight, I think. Actually, we got a millimeter of clearance, I think. Let's see what it is. Half of the problem of working with fusions is it's only 0.5 millimeter clearance. Let's make that a little bit more. So I'm just going to hit Q minus 0.5 and just pull that in a little bit, so that this is not going to rub in with our body. Oh, that's my old servo base. I'll eventually delete that. So right now we've got clearance between the spinning part and the static part in our build. So let's take this and again, I'm going to hit Q. And when you're working with circles, the number that comes up is the radius of what you're designing. So if I wanted it to be 10, that's going to give me a diameter of 20. Inspect. See, so it can be a little confusing because most other times you pull up the Q key, you're going to get a direct number. Like if you want to come back 3 millimeters. Usually what I do in that situation, if I know the exact clearance, I'll just use this as and do the math right here. If I want to come in 1 millimeter or half a millimeter, you can see I just do the math, and you can do times 5. I mean, it actually does the math for you. So it's really nice and really handy just to type in easy equations when you're doing your work. So I'm going to leave this this central spot open pretty much right now for because I don't know exactly what we're going to do with this space, but I do know I need to get my motion translated through the walls of where is it? Body rings. Oh, I turned them both off. I want to get the translation in through this hole. So let's start with a sketch. Turn this off. We'll do a sketch right here. Create sketch. And we'll draw a circle based on the center here. Oops, circle, C key. And we said our radius was 25. Let's go with the 23. Finish sketch. And now we're going to extrude this. And my first thoughts already is that's a little thin, and I'm probably going to end up making this larger. So you notice when I did my extrude, it's going to join. The operation is join as opposed to new body or component. I'm kind of happy with that right now, but if I were scared about it, I just make it a new body and then combine them later on. So how far out does this go? Well, let's take a look. Somewhere in here, we know it has to go at least to here, which turns out to be 14. And then again, if I know I needed to be a 1 millimeter clearance as a minimum, I can just go +1 or whatever this, say that wasn't exactly 14, say it was 14.358, whatever. I can just straight up add the clearance right there in my extrude command. So, and just to stay in good form, I'm going to take this and join it to that. And again, this is kind of an optional thing. You don't have to work that way. You could have just gone with a straight extrude. And I'm going to bring this into -3. So whatever we're going to pass through is going to have to go through this little channel here, which is 13 millimeters. That's pretty good. You can fit a connector with a grabber or whatever. You can fit through this hole here. Let's see with this. All right, so anytime I'm looking at a body, I look at the detail of what is built into it. You can see I've got a face here and a face here. This should all be one face, and you can certainly leave it as is. But if you can get rid of this one, it's going to be less computational power and just a cleaner model. And I've kind of I kind of like keeping as few faces, or in this case, boundaries as possible. And that's just a little housekeeping thing. All right, so let's take a look at where we're at. Now, how are we going to get this into a tool? Well, we have to have a surface to draw on, and we have to have a kind of a concept of how big our thing's going to be. So let's try to do this. Body rings off. Create sketch. Let's sketch on this surface here. And I don't know why Fusion does that, but it annoys me. All right, so now I'm just going to bisect the center of this circle and use that as a basis of the rest of the design for the tube that's going to be the arm. So when I draw this, the things I'm paying attention to, you notice these little dots here, or those are constraints. If you look up at the top, these are called coincident. So that line is coincident with the center of the circle, which is what I want. This one is a horizontal vertical. That's also what I want. I don't want some weird angle. And then this one's coincident with that. So that's half of what I want. Although I could use that, I'm going to extend, modify extend. And you can see now it's going to build a line that's centered on the center of the circle and goes from this tangent point to that tangent point. And that's exactly where that line is going to behave itself. And I'm going to leave that there. And what we're going to do with that is I'm going to go to construct, plane at angle. If I can find it, here it is, plane at angle. And the line I'm going to select is this one. And it just so happened it came up with perpendicular, which is what I wanted. But if it didn't do that, I could change the angle here. I'm just going to leave it as is. And here's a little fun thing. I'm just going to drag the corner of this plane out a little bit. And that's just cosmetics, just to kind of give myself a representation of how big a space I'm working with in my my lifter. So that kind of bullseyes the center mass of that chamber. So now we're going to put a sketch here. And again, it spun it for unknown reasons. One more. There we go. So now we want to build a tube that's kind of centered on this, this line here. And the center is the center of that circle. So first thing I'm going to do in my sketch is select that line and project that geometry into my sketch so I have that as a reference. And we're going to draw a circle, although we don't have to draw a circle. This zapper could have anything, but it seems like they use, for the most part, round tools. And I'm just going to randomly put a circle here and inspect. This one is 23 millimeters wide. So let's just say for fun, it doesn't have to be that wide, but it might. Let's just try making it that wide. So I hit the dimension key, click on the circle, and you can see I almost nailed it, 23. All right, so finish sketch. So we have a circle that's kind of centered in the center of mass of our point of rotation. And I'm just going to extrude this down. And we don't know how long or how big this tool is going to be. But let's just say it's something like that for the arm. Now you notice it turned red. What that means is it's cutting through. On my model, what I did is I added these little thermal pads to help with warping that I cut out when I did my mod of the Mark III. I don't really want to cut that, so let's just go with new body and know that in my mind this part doesn't exist. In fact, appearance. And I'm not going to mess with that. I was going to find something transparent to put that so it wasn't as obvious. Anyway, so now how are we going to join this to this? Let's turn this body off. And there's lots of ways of doing this. Let's see if we can find something that looks kind of cool. So let's get back to our, how are we going to put this together as one of our core concepts of, my cat's freaking out. One of my core concepts of how's this going to go together? Well, I imagine we'll mount this bracket and then, or we'll mount the gear in the bracket and then mount the bracket to the droid. And so this little piece here is going to be sticking out. Then we have to mount this tube to that arm. So we don't want to join this all together, is my point. So there's going to be a joint here. And to do that, I've chosen with this build, we're going to use magnets. So I went online to K&J Magnetics, and they have step files of their basically models of their magnets. So that's what this RC62 as a component, that's a magnet. So what I want to do is have one of those magnets in each of, one in the base of my gear assembly, and then one in the arm. So I want to keep that in mind. So let's turn magnets, turn that one off, and you can see just magically that magnet's right where I want it to be for this design. Let's just go and install that magnet real quickly. So let's turn this, I'm going to call this, just rename it real quick so I don't lose track of it, Arm Proto. We'll turn that off. And probably the simplest way of doing this is combine the gear with my magnet. And it's not liking my selection because I'm selecting a component. So I have to drill down into the bodies and, oops, not the lifter, but the magnet. And I don't want to join them. I want to cut, and I also want to keep tools so that my magnet's there for further reference. And now you can see that that magnet has a hole to live in, but with all things, we can't accept that as is. Let me turn this sketch off real quick because it's going to have clearances. So we're probably going to put a little glue in there. I usually use super glue with a zip kicker. So let's offset this face by 0.3. We don't want to put it too deep because if we don't put enough glue in there, the magnet's going to be recessed into that gap and it's not going to touch. And we want those magnets to touch exactly. So I don't really want to go, in fact, I'm going to go 0.25 because I'll have room for a little bit of glue, but I don't want it to be so much that it's sitting indented into my gear mechanism. And for the clearance here, again, this is a radius and this math gets funky to me. So let's just add 0.5 millimeter clearance because it's less important that this is exactly centered. It kind of will be naturally, but having a little slop in the rotation is not going to kill the design. All right, so at this point, my biggest concern is the magnet having enough grabbing power not to spin when I spin my gear. And based on, I actually have these magnets, and I don't think that's going to happen, but eventually you might want to put a little a tooth or a square nub on this assembly so that when it interfaces with my arm, it has a little something to transfer the torque of spinning that gear. All right, so let's just go for now that's our base design, and we'll go back to our prototype, and let's have a place for this magnet to live. So here's kind of a fun thing I'm going to do. I'm going to go here, construct offset plane, and I'm going to take this offset plane -1. And this is just a quick and dirty. So I'm going to split body, this body here. I'm going to split it with this here, hit OK. And then I'm going to mirror my thing I just made, this. But now here's a problem with mirror. Notice what it did? It just mirrored that face, and that's not going to create something rational. So I got to find out where that face went and select the whole body. There we go. In fact, I don't want two select, I just want that. And mirror plane, I'm going to select the face of that and create a new body. And then when I'm done with that little, I'm just going to put that back together. Join. And then this, I'll hit the V key, make that go invisible. And so right now that's exactly touching the other surface there. So where's that body? So what happened is, I wasn't expecting this. This spur gear 4411 that you see here actually ended up inside the spur gear component. I don't want it there, and I don't like the name. So the first thing I do is call it arm magnet spot. I don't know what to call it. And then I'm going to hit right click, move to group, and we're just going to put it up into the main project here. So now it's not tangled up and caught inside my my spur gear component. All right, so just for fun, I'm going to offset this by 0.2. Let's make it 0.1. And then I'm going to offset the part I brought in by the same amount. So Q minus 0.1. So that gives me just a little bit of extra clearance in my design for those two pieces to go together. So what we're really going to do now that we've done all this preamble is make this merge nicely with that. And let's see, this is kind of a nasty problem to solve, but you can imagine you want this to be curved in all the dimensions and meet that face there. So let's work on, and then probably this face to be curved into that face. And you might be tempted to do it with an extrude. And you could see that's kind of approaching what we want to do. Let's come, if we did an extrude to here, to the halfway through, 23 divided by, actually, I don't remember. Let's see. So 11.5 is the radius. So if we were to extrude 11.5, that'll take us, nope, it's not, because cancel. One more time. All right, so I'm just going to put a little reference line of where I want to extrude to. Extrude to, can I grab it? No. I thought I'd be able to grab that line as a snapping point. I guess it has to be a body. So I'll tell you what I'm going to do. Undo finish sketch, and I'm going to take my extend tool like that, my trim tool T, get rid of that. I don't like having little things sticking off because that can create weird faces. And I'm just going to give it a spot to hit, and I'm happy to have those join. And even though it's 1.183, it doesn't matter. I'm just going to make it 2 because I don't like weird math. And now I'm going to extrude this one more time. And then I'm just going to snap to that face. So I know it's right in the center of that tube. And you can see this joint looks pretty good. I like the way that's going to look, but I don't want it to join it just yet because I've got some other work to do. So I'm going to make this a new body. You can see that that gives me body 139 here. So let's do this. Let's do a split body. This is the one we want to split, splitting tool, either one of these arcs. And let's turn these off for a second. And that gives us a little slice out of our arm prototype. Where'd this go? Of arm proto. So you can see in our, we got some weird geometry here that I don't like that at all. Oh, it's caused by these things here. That's why. So let's back up a little bit. Undo split body. What I was hoping to do there is just have a nice little cut right here that is going to end up joining there, because we've got some other geometry here we need to preserve. And I was hoping to cut it out and just delete this chunk that was resulting, but it didn't turn out as nice as I thought. So we'll just leave it as is for now. I'm going to put this back to where it was, -2. And you can see that it kind of left two faces here. I don't like that. So let's turn this off. And I'll hit the Q instead of extrude. And put that body back together. All right. So what I want to do is curve this piece from here to here. And this is going to be something that is a loft. And we have to prepare for that. So create sketch here. And it's going to be a line from here to there. And I'll extend that to the other end. And that gives me kind of a semicircle, the undo finish sketch. So here, I don't want this line involved in any of the math. So I'm going to hit the X key. And if you notice, it turns to a dash line. So now when I am trying to select this geometry, I get the whole hemisphere as opposed to an arc. And the last thing I need here is a line from the very center of that to the edge of that. So now I've got 2 quarters. Don't worry, that phone is just going to ring in the background. Nobody I know calls me on that phone. All right, so the last thing we need is a little guide rail for our loft that goes from here to here. So probably the easiest way of getting that is to go to construct, plane at angle, pick this line here, and it's created a nice perpendicular plane for us to draw on. I'll hit OK. And now we're going to create a sketch on that plane. So for curves, do we have a question? Okay. I'm just going to take the curved line. First, let's bring in some geometry. So I'm going to click this, hit project. I'm going to click this. So I've got 2 items selected. So I'll be able to grab that point and hit OK. And what we want to do is draw a nice, cool looking curve from here to here. So I'll hit the spline button, grab this piece, and I'll put one here and then this piece. When working with splines, less is more. if you put way too many points, it'll create a more complicated curve, but it's also gonna be more complicated for you to manage that curve. So I may have been able to get away with 2 points as opposed to 3, but I'm just gonna go with 3. So this, if I don't want a weird bump, this has to be tangent to this face here. And since this is perpendicular, I can cheat and just make this little arm horizontal. And now this is tangent to that. I'm going to do the same thing here. So there's not going to be a weird bump as these two surfaces join each other. And now I just have to manage how I want this. You know what? I'm going to get rid of this point. I can create this curve where I like it just by using 2 points. How's that look? Reasonable?
Yeah.
I think it does. All right, so now what I'm going to do is create a loft. And I think I can do it in this as a solid, but if not, I'll have to go to you know what? I'm missing a face. I need another sketch on this face here. Create sketch. And now this I just did is something risky. I just eyeballed where that should go. And I don't know if I actually hit it or not. So I'm going to actually not even take that risk. I'm going to go back to where I was before, just start at the center, go to a known point here, and extend it. There. So now I have, I think I need this one too. So undo. All right, so now let's try this create loft again. And then, oh, I think I've got too many faces. Create loft. And then this may work, guide rail. Oh, don't extend the chain. All right. That's not working. Try one more time. I need this to bow out a little bit more, and I thought I'd be able to grab this this surface here and have it follow that as a guide rail. But it says loft cannot be created, try changing the input. So so the problem I'm getting here, see how the rail that I'm selecting is the whole arc. That's too far, and it's the math is too it doesn't understand that math. So we need to break this line up in our sketch. Edit sketch. And I thought that I had. Let's select this and hit X.
I wasn't sure if it was different like at the appointment. The car in front of us.
I don't use loss very often, so that's why I'm kind of fumbling a little bit here.
Tim, can I ask a quick question?
Sure.
Sorry, did that not work because, you know, that radius you created? Is it not because it's this, because it is not the same diameter as the tube you're trying to replicate?
This radius here?
Is it,
No,
is it profile 2? That one. Yeah.
No, this radius and this radius are the same. And
Right, okay.
the wild card is this arc we drew. And the problem
Yeah.
is I need an arc from this point around the out to that point. And
right.
So to do that, and this is not very elegant, but I'm just going to create an arc that is what I want by using the arc, center point arc, and go from here to there to there. So now my wayward loft should be working. So here to here to here, and then rails, I'm going to use that. Oh, come on. It says rail is not smooth. Well, this worked in the practice, believe it or not. These things can be tricky. So let me try one last time, and then I think I got this.
I guess you could do a revolve on that, couldn't you, Tim?
You could, and that's a good point. That sometimes you get stuck trying to do a particular what do you call it, feature, and it ends up, you end up spending a lot of time working on that, only to realize now you need to watch a couple YouTube videos. But your suggestion is probably the most expedient here at this point. And angle to here. $180. That's probably the easiest way of doing it. I have to look at my lofting. So I'm not going to make that a join. I'm just making a new body. And then we'll get rid of this nasty lofting sketches and turn these bodies back on. And you can see kind of where we're going with all this.
I think it was the profile that you created using the what's the tool called? The bendy line. Didn't match. Yeah, sorry. So the spline didn't match the profile of the circle. So where you were doing it from, so it's probably having to shift that profile out very slightly to the middle bit and then back again, which probably confused it.
Yeah, like I said, those splines are hard to work with. And when I did this for my example, which where is it here? You can see I created a nice, that I used the lofting commands for all that, and but either way, for the purpose of instruction, I will have to revisit my lofting chops to be able to recreate something that is smooth. So that's looking like a pretty good arm. And now I just have to slice this up, cut a hole in it, and join all these pieces together. And I'll have a usable magnetically attached lifter arm that can be then turned into some kind of a tool at the end. And we've been going for an hour. Do we want to kind of stop it here, or open up for a couple of questions if anybody has any things that I glossed over?
Yeah, we can open it for questions if anybody's got any questions, observations, or comments.
Hey, this is John. I from the very beginning, I could kind of see the train of thought of where you were going with it. I think the way you explained it was really, really good because I could kind of anticipate the next steps, and it makes a lot of sense to me. So I'll just have to give it a shot building it, but I think it was very well explained.
Well, thank you. When I approach a design, I'll spend a lot of time not drawing anything, but just kind of visualizing the what problems I need to solve. Because as you design more and more, you kind of have a little bag of tricks and ways you go at putting things together. And you could see me guessing on some of the clearances. That's just kind of based on experience. I'm not looking at a table of this clearance is required here, and therefore that's what I clicked on. But you kind of do land on some kind of presets based on your nozzle and the material you're working with and those types of things as first guesses. And I say first guesses is if we were to print this out, we'd find some problem with it we didn't realize and then have to iterate a little bit on it.
Yeah, visualize with not necessarily with this, but with other types of things that I create. I can get pretty close, and I understand exactly what you're saying. You know, you can get close, but the Fusion 360 with the different faces and the angles and combining bodies, I could see where if you just try to wing it, you might end up with things not computing right and calculating out right.
Yeah, and I always try to go with the few amount of faces as possible, and I always zoom in on things. Like, see how this little tail right here? There may be something funny with that joint. If I were to try to combine these two together,
would that be something that cause a problem down the line? You were going to
it
make
potentially
this?
could.
Okay.
In that it looks like it goes together now, but later on you may find that little tail, that little extra face, or that thing that didn't merge perfectly, when you start manipulating it, could cause the manipulation to fail because there's some kind of infinity math in there that they don't actually quite touch, or they're touching at an angle that is so acute or obtuse that it causes the calculation to fail. So I'm always on the lookout for weird looking geometry, extra faces that don't belong. And I really try to solve them when they show up so that I don't have to deal with them later when I'm trying to modify things.
Thank you. Okay.
Yeah, as well
All
explained, Tim. I missed the first one, I'm afraid. I think I was out, and obviously did the Gonk one with Michael with the 3, and seeing all the things in here are great just to see how it progresses into bigger things. But understood most of the stuff you were doing with only ever done the Gonk. So yeah, it's well explained, really good.
Yeah, well, if we have a third one of these, what I'd like to do is kind of do a little bit of a deep dive into components and how to do how to use components to, particularly on moving things, to get predictable motion, or at least have an idea of what motion to expect. I'll just do a little quick preview while we're here. To make motion work, you have to have everything as a component, and you can define joints, and we can, like I said, this is basically what I would like to talk about, is driving your joints. And you can get the range of motion and get an idea of what this component will actually do in the wild. And so maybe if you guys want to do another one, we could kind of dive into how I've made that little bit of wizardry work, or black magic.
Yeah, I think that'd be superb, Tim. Be useful because the challenge, well, not the challenge, but the fun of Fusion is it's layers upon layers upon layers. So when we went through the Gonk, that's kind of like the very basics, how you create solid objects and link them together. And then what we're digging into here then is more of the detail around sketches and constraints and components, and some of the more advanced stuff like creating gears and the tolerances associated with it. So jumping into then the components and how you link them together from animation perspective, I think would be really useful.
Yeah, it's all fun. It's like you deciding to build a Rubik's Cube. First you have to design it, then you have to solve it.
Yeah, the biggest design challenge is what mechanism do you actually choose for the problem that you're trying to solve? That's what I always find. It's different than if you were to grab something that somebody else has already done and tweak it a little bit, but actually starting from complete scratch, and how does it fit together? The other failing that I have when I translate from Fusion to real world is generally an assembly. So I won't leave holes for screws, or I'll forget that you need a big hole there to be able to get a screwdriver and a screw in there. Just assume that you can somehow get tiny little elves in there to attach it all together. And then you have to redesign it to put all of the assembly holes and constraints in.
That's and you notice one of the things I did talk about in the design concept is how does this go together?
Yeah.
How do I envision this being assembled? What order do they go together in? Because it's very easy to design something that is like a ship in a bottle that you can't actually put together.
Yeah, exactly. Brilliant. Right. Well, if there's no more questions, I think we can wrap this session up. I'll pop the recording on the YouTube channel as well and share it, because I know it's a lovely time between Thanksgiving and Christmas. So lots of people are in different places with family, etc. But that's perfect, Tim.
All right.
We'll look forward to session 3 and looking at components.
All right.
Yeah, wonderful. Thanks, Tim.
Cheers, guys.
And thanks, Michael.